Next topic in the digital system design is binary codes. As already we had discussed in the previous class, number system and its types: binary number system, octal number system, decimal number system, hexadecimal number system. Now we are going to discuss about the number conversion. First one is decimal to binary conversion. For example, now we are going to take the value as 17 with the base 10. So in order to convert the decimal number into binary number, we need to divide by 2. So the 17 divided by 2, the remainder is 1 and the quotient is 8. Again, the 8 divided by 2, the remainder is 0 and the quotient is 4. Again, the 4 is divided by 2, the remainder is 0 and the quotient is 2. Again, the 2 is divided by 2, the remainder is 0 and the quotient is 1. So, finally, we are going to take the values from down to upwards. So, the value is 1, 0, 0, 0, 1 with the base 2. So, the 17 with the base 10 is converted into the binary value as 1, 0, 0, 0, 1. The same thing we are going to follow for 115 with the base 10. Again, we are going to divide by number 115 with the base 2. So, finally we are going to get the answer as 111, 00, 11. So, the decimal number is converted into binary number. So, in order to convert the decimal number into binary number, we need to divide the base value by the decimal number. So, the base value is 2 for the binary. So, we are going to divide by 2 the decimal value. Then, we are going to take the value from down to upwards. Next, 10.625 with the base 10. It is a decimal value. So, now we are going to convert the decimal value to binary conversion. As already we discussed in the previous slide, how to convert the value. So, for the integer value 10, we are going to divide by 2. So, the 10 will be divided by 2. The remainder is 0. Quotient is 5. Again, the 5 divided by 2. The remainder is 1 and the quotient is 2. Again, the 2 is divided by 2. The remainder is 0. Quotient is 1. Again, the 2 is divided by 2. The remainder is 1 and the quotient is 0. So, now we are going to take only the carry values. So, from down to upwards, the carry values. So, the final value is 1010. This is for integer part. Then for fractional part, we are going to multiply by 2. For integer part, we are going to divide by 2. For the fraction part, we are going to multiply by 2. So, 0.625 into 2. What is the value? 1.250. We are going to take only the integer value. So, the 1. Then, the remaining value 0.250 into 2. So, the value is 0.500. So, we are going to take the integer value. The integer value is 0. Next, the fractional part 0.500 into 2. What is the value? 1.00. Now, the fractional value will be 00. The integer value is 1. So, we are going to stop the process. So, for the integer part, we are going to take the value from down to upwards. For the fractional part, we are going to take the values from up to downwards. 101. This is the difference for the fractional part conversion and the integer part conversion. So, for integer part, we are going to divide by 2. For the fractional part, we are going to multiply by 2. Then finally we are going to take the carry value, and then we are going to find out the value as answer as 1010.101 with base 2. This is the decimal to binary conversion. Next is decimal to octal conversion. So already we have discussed for the decimal number to the octal conversion or any conversion, we are going to divide by the base value. For the binary, the base value is 2. For the octal, the base value is 8. So we are going to divide the decimal value by 8, and we are going to write the remainder parallelly. So 33 as a number we are going to take as an example. Then we are going to divide by 8. If we are divide by 8, the remainder value is 1 and the quotient is 4. Again the 4 is divided by 8. The remainder value is 4 and the quotient is 0. Again the same, we are going to repeat it from, we are going to check the remainder values, and then we are going to write the values from down to upwards. So the final value is 41 with base 8. So this is the decimal number to octal number conversion. The same procedure we are going to follow for 1486 with base 10. So again we are going to divide the number 1486 divided by 8. We are going to take the remainder values parallelly. Then we are going to take the values from down to upwards. Finally we are going to get the value as 2716 with base 8. This is the decimal to octal conversion. Next we are going to see the same for the fractional values. So for example 540 with base 8. The same procedure we are going to follow. We are going to divide it by 8 and we are going to take the remainder values. Then we are going to write it from down to upwards. So 540 base 10 is equal to 1034 base 8. Again we are going to follow the procedure for the 29.30. As already we have discussed in the decimal to binary conversion, for integer part we are going to divide by 8. For the fractional part we are going to multiply by 8. The same thing we are going to follow here. So finally we are going to get the answer as 35.23146 with base 8. This is the conversion from decimal to octal. Next thing is decimal to hexadecimal conversion. In decimal to hexadecimal conversion, we are going to divide it by the base value. So the hexadecimal base value is 16. So for example 91 we are going to divide by 16. Then the quotient value is 5 and the remainder value is 11. So for 11 the hexadecimal value will be B. So we are going to take it from down to upwards. So 5B with base 16. The same thing we are going to follow for 675, 6749. For 675 the value as 2A3 base 16 and 6749 the value as 1A5D with base 16. So the decimal numbers are converted into hexadecimal values. Now we are going to see the example 374.37 base 10. For 374 we are going to divide by 16 and we are going to get the value as 176 base 16. For the integer part 0.37. So for 0.37 we are going to multiply by 16. Then we are going to take the carry. So finally we are going to get the answer as 176.5EB8 base 16. So as a summary of this class, we have discussed about the number conversion. The number conversion, how to convert the decimal number into binary value, and the decimal number into octal value, and the decimal number into hexadecimal value. Thank you.